Whew. All right, we're here. Well, I guess this video doesn't seem that weird to you, but this is my third video in a row. I made two other videos in about, what are we at now, 40 minutes? So I'm already at 40 minutes of recording. I'm going to assume by the end of this, I might be at 60 at least. Here we are, though. Factoring polynomials review. So a review on how to factor polynomials. There's a variety of problems in here. There's 11 questions. Strange number, I know, but I felt like 11 was appropriate after looking over all the test questions. It gave me enough types of the same question so that you can show me you have mastery of like the most common types of factoring, and then a good smattering of the other kinds of factoring you'll have to do. I think you'll see what I'm talking about when we get into the assignment. Anyways, enough justification of why your assignment is 11 questions. Let's just do them. Okay, number 1, it says factor 5y squared plus 12y. Now here's the rules for factoring. Rule number 1 is when you're starting a factoring, you should always do the first thing is, can you divide out something from all the terms? In this case, there's just two terms, but can you divide something out from all the terms? So let me write them down real quick. 15y squared plus 12y. Yes, I can divide both of these by 3. And I can divide both of them by the letter y. If they both have letters that are the same, you should take that out. Now, your problem could be different. I've seen it plenty of times a day. People had like cubed and squared. If yours is like higher than what I have, like bigger exponents, you have to take out the least thing you see. In my case, the least thing I see is just plain y. So that's all I can do is take out plain y. But if I had had y cubed and y squared, I would have been able to take out a y squared. But I can't this time. Just telling you what could happen, because I don't want you to be confused if you're watching this and trying to do your problem and thinking this isn't right, because maybe you need to take out something squared instead of just plain. All right, anyways, if I take out 3y, the way you now continue to do this is you write everything you could divide them both by, then you write the results. Like if you take 15y squared and you take out 3y, what's left over? 5, because 15 divided by 3 is 5, and y squared turns into y. It's like you removed 1 from the exponent. Second term, what do you get when you divide 12y by 3y? Well, 12 divided by 3 is 4, and the y actually goes away, because if you've taken out y from y, it's nothing. Guess what? That's the answer. Done. Easy. Now, I said the first step you should do is just factor out what you can. The second step and third step are to see if there's further factorings that can be done. In this case, 5y plus 4 can't be factored. How do I know that? Well, you can't factor stuff if it doesn't have like squared or higher on it usually to some degree. So in this case, no more. So be prepared for a problem number 1 that is, to have something that you need to factor out, probably a common number and probably a common letter from the probably 2 terms. I don't know if it's going to be more than 2 terms for you. All right, next one, factor by grouping. Now, earlier on some assignments, if you've watched any other of my videos, I took a few problems and I did a little x cross thing and I put some numbers in it, and I did bottoms up method to fully factor it. And then I had another method called the box method. When you have 4 terms, you should do the box method. You don't have to do the x though. The x is for when you're trying to figure out how to split 3 things into kind of 4 things. Well, here you already have 4 things. So the box is the next step. I don't have to write an X and cross anything or do anything. Just get your terms and start writing them in there. Now you're probably thinking to yourself, do I have to write them a certain way? I would write them in the same type of order. I'm writing them first, second, third, fourth, top, bottom, bottom. If you mix the the middle 2 around, you still get the same answer. Now when we did this on any other assignment, we decide what we can factor out from each row and column. I'm going to start with the bottom row. I know that seems weird, but 9u and 12 are both divisible by 3. I'm going to jump to the right column. Negative 4 and 12 are divisible by 4. The first column, 3u3 and 9u are divisible by 3 and u. Be careful. A lot of people are doing this thing where they're dividing the numbers by each other. Like on the second column, I've seen people that would have answered 3 because they were doing 12 divided by 4 is 3. That's not what you're writing outside. You're writing what number goes into 4 and also goes into 12. The answer is the number 4. All right, this column I wrote 3u because 3 and 9 are divisible by 3. And I also wrote u because both things have at least u in it. Kind of like my first problem. It had a common letter to divide out. The first row I saved for last because it's the one that people seem to forget most often. It's u squared. Where am I getting u squared from? Well, 3 and -4 don't have anything in common I can divide out. But there are u's on both of these terms, and in fact, the second term has u squared, and the first term has u to the 3, and since u squared is the least amount of u's I see in one of these, I can take that much out. Whew! Now, I'm not done. 4 times u squared does not make -4u squared. Something's wrong. These outsides need to multiply to make the insides, but I have some negative stuff and no negative signs to be seen. So -4 and -3 are required because that makes the -4u squared possible and the -9u possible, and it still keeps the 12 looking regular. Sorry, that was a lot of explanation. Factoring by grouping is, not, the quickest process in the planet. But you gotta know how to do it, man. All right. Hey, by the way, I wrote the side things together. So u squared minus 3 became a term, and 3u minus 4 became a term. You should always still check. Could something be factored? We actually learned the other day, or the other video, that u squared minus something sometimes factors again. Like u squared minus 4 would split into u plus 2 and u minus 2. But u squared minus 3 cannot be factored any further. Just so you know. That was a doozy. All right, let's go to some easier ones now. So we've seen factoring out a common number and variable. We've seen factoring by grouping. The next, I think, 3 problems are all basic factoring. If you can do anything on this assessment or even this assignment, I hope it's this. When you have 3 terms, you want to go for one of these. Ideally, you don't want 3 terms. You actually want 4 terms. So you can factor by grouping, use the box that we used or whatever. So we're going to use this cross to figure out how to split it into 4 terms. What multiplies to make 20 but adds up to -9? I'm going to need a little bit of guessing and checking if you don't know, but let me write out some options. 1 times 20, 2 times 10, 4 times 5, and it's 4 times 5. Because 2 times 10 can't make 9. It can only make a 12, maybe an 8. You got to kind of think of what adds and subtracts here. Like 1 plus 20, 1 minus 20. 4 plus 5, 4 minus 5. So in this case, the only way to make -9 is these both be negative. Now I said we're doing this to split the middle term, -9 into -4 and -5, so you could do the box. But the fun fact about these ones is you can just skip to the answer. Y minus 4, Y minus 5. And I really do want you to skip to the answer after you've done that process. Normally, or in some cases, you need to further work stuff out. But in this case, if you worked it out, it would just come back to being this, and these were the numbers you got anyway. So it's kind of like excessive. Whew, that's a lot of speaking I just did there. Let's do another one. So this next one, let's just start, and I'll write an X. I'll write a big X. -12 is on top. There's no number in the middle, but it is technically 1, right? X is 1x. What multiplies to make -12 but adds up to make 1? That would be a -3 times 4. And therefore, the answers are x minus 3, x plus 4. Simple. It should be that simple. It should be you write an X, you figure out what multiplies to make the number on top and what adds to make the number on bottom. You will want to make sure you put the correct numbers on top and on bottom. Oops. Guys, don't look at any of that. You didn't see any of that. I'm clicking all kinds of wrong stuff here. Back to the review. I clicked on 8.7 on accident. All right, sorry. Again, if you've seen an earlier video, my mouse has side buttons, not top buttons. They have side buttons, and if you click the side button, apparently it takes you back. It takes you backwards on your web page browsing. Go figure, how intelligent. All right, on this one, I'm not even going to write it out. I can look at it and say, what multiplies to make 16 but adds up to make 10? 8 and 2. So x plus 8, x plus 2. I mean, look at it. X times x makes x squared. X times 2 is 2x. 8 times x is 8x, which adds up to 10, by the way. And 8 times 2 is 16. Perfect. Now, when it comes to assessment time, you will probably be asked to show me how you got that. So I'm just saying, if you get it mentally, fantastic. But you better be prepared to write it down. All right, number 6. There's a number out front. Oh no. But as I said on problem number 1, the first step you should always take in a problem is see if you can divide something out. On the last 3 problems, the first term never had any number in front of it, so I never thought to divide anything out. But here, could I divide something out like we did on problem number 1? Well, I can't divide out a W like we did on the first problem. We can't divide out a letter, but I can divide all these by 2, the number, which gives me W squared, 10W, and negative 24. Like everything got divided by 2, and those are the remainders, right? Hey, check this out. The thing that's left over now can be factored just like we did on the last 3 problems. What multiplies to make negative 24, but adds up to make positive 10? Be careful. 6 and 4 is very tempting because 6 and 4 make 10 and seemingly make 24, but the actual correct answer is 12 and negative 2. A 6 and a 4 wouldn't be able to make positive 10 unless it was positive 6 and positive 4, but that would never make negative 24 when multiplying. So sometimes there's like fake out answers that kind of seem okay, but they're really not. Anyways, I get 2 times W plus 12, W minus 2. Notice the 12 and the 2 get split, and that 2 I took out front still is out there. If you're wondering why I'm saying that so matter-of-factly, it's probably because I just did the lesson in which you have to factor this out. So in my mind, I feel like I've already talked about it tonight, but from your perspective, I just want to make you understand sometimes a number can be divided out of all the terms, and you should do that because it'll simplify what's left over. Same thing here. There's a 5 out front. Ooh, can I divide all this stuff by 5? Well, no. 12 and 7 are definitely not divisible by 5. So you have to use regular factoring. And boy, howdy, we love that. Now, we've been making this x, right? This is different. If you got a number up front, some new rules apply. Rule number 1, that number up front multiplies to the end. So we get 35. And what multiplies make 35 but adds up to 12? Wow, big shocker. It's 5 times 7, the numbers we just had that multiplied. Hey, sometimes you get lucky, you know? Then I go to write my answer, z plus 5, z plus 7, but that's not right. There's more to do. So I said there's something to do if there's a number front. Now, one thing to do is you multiply it. Number 2, and this is only if you're using the bottoms up method, which I am currently doing, I'm going to divide each of these numbers by 5. That does some corrective math voodoo and causes you to get z plus 1, 5 divided by 5. And on 7 divided by 5, you can't divide. So it's called the bottoms up method because if it doesn't divide, you bring the bottom number, 5. I don't like that 5. Bring bottom number 5 up to the z and put plus 7 afterwards. Now, we've talked about this at length in class. This is the fastest way to factor these things, so I'm probably going to be using it. If you're somebody who likes to make a box, oops, put a 5 on accident, you might want to come see me about that because I don't mind using that method. I just want to do it myself. Oh, I did the most commonly dumb thing ever. I put an x instead of a z. Just make sure, hey, oh my gosh. Okay, if you're watching the video, I'm assuming this isn't a you problem. But I've had so many people miss problems because they get a dialog box. My dialog box just said make sure you're using the right variables, which indicated to me that I had put an x instead of a z because I like to put x a lot. If you get a dialog box, this is what now I'm talking to students now. If you get a dialog box, how about you read it? Because I get people that do this thing where they get a dialog box that just says, "Hey, make this little correction that I think you'll understand what I mean." And then kids just hit enter again and get it wrong because they're like, no, I refuse to read one sentence about maybe a small error that I'm about to get dinged on. Now, don't get me wrong. After the test is over, you can come to me and say, oops, I accidentally wrote X instead of Z. But it'll make life all the easier for us if you just do it right the first time and read the dialog box. Oh, intelligent students. If you're watching the video, you're probably so smart you don't need to know that you need to read the dialog box. Whew. Okay, next problem. 3y squared plus 32y plus 20. I can't divide out a 3. Sorry, only, no, nothing's divisible by 3 in this besides the first term. So we gotta cross it over. We get a 60. We get a 32. What multiplies to make 60 and adds up to make 32? Ooh, rough call. 60 is a kind of biggish number. Well, 30 times 2. So we get y plus 30, y plus 2. Remember, this is not correct. You have to correct it using this bottoms-up voodoo. 30 divided by 3 makes 10, the new true answer. And 2 divided by 3 is impossible, so I bring the 3 up to make 3y plus 2. So that is me using the bottoms up way to factor here. Notice it wasn't like super longer compared to the ones that didn't have a number in front. I mean, there's a little bit more to it, but still totally fine. I guess the big hang up here for a lot of people will be, can you figure out what multiplies make 60 and adds up to make 32? I have no perfect method to describe to you guys on that one besides telling you, if you don't know, start writing it down. 1 times 60, 2 times 30. You could stop right there and say to yourself, wait, 2 times 30, 32. Oh, I'm done, right? Like, but if you have to go on and write it all, there's a lot of options that can make 60, right? 5 and 12, 6 and 10. Okay, that's all the options. I know I'm getting close to the end of the options because when the numbers get closer together, you're done. Like 6 and 10, the next option would be 10 and 6, but that's just 6 and 10 backwards. You should always never ever go past a number times itself. Like if the last thing was 8 times 8, I'd stop. I'd be like, okay, everything up to 8 times 8 is fine. Because otherwise I'm just going to rewrite this list again, but with the numbers reversed. Hopefully that explanation I just said makes some kind of sense. All right, here we got a special case. Do you recognize that it's a special case? Probably not. So if you don't recognize it's a special case, you are more than 100% welcome to go, what multiplies to make 64 and adds up to 16, and you can say, oh, it's 8 times 8, and then your answer will be y plus 8 and y plus 8. Now, that is almost that's as quick as you can do the problem anyways, right? But if you notice it's a special case by looking at it and saying, oh, 8 and 8 make 64, 8 and 8 add up to 16, you can probably just jump right to writing the answer. Of course, on your test, I would love to see some work, though, probably. So, make sure you write a little bit like what I wrote there. Oh, yeah, this is true, too. You could write y plus 8, then square it. That'd be an equivalent answer. Here's a special case as well. I don't really want to write down too much work here. You don't really need work. You just have to recognize that 4 is 2 times 2. So 2z times 2z makes that. And 25 is 5 and 5. How does that work out into an answer? 2z plus 5 times 2z minus 5. I mentioned it was a special case. The special case is this. If you got two terms, you can make it just you can factor two terms if both of them are something squared. So 2z times 2z, that's something squared. 5 times 5, that's something squared. And then when you write your answer, you write the positive version of that and then the negative version of that. Notice on this one I didn't bother to see if I could factor anything out on the front. Sorry, 4 and 25 did not have anything in common. We haven't had anything that both could factor out of for a while until right now. Spoiler alert, number 11 here is doing that. Number 11 on a test probably going to be doing that too. I hope people can answer these on test day. These are not the easiest problems, all right? I want to be first to admit that, okay? No hate if you struggle. All right, last problem. Can I divide something out first? Yes, I can divide everything here by 2, u to the 3. Please make sure that you take both a number and letters out. You can't take out anything more than what the most smallest exponent is. So 2u to the 3 is what I can remove. That gives me 5u squared left over, 17u in the middle, and 6 at the end. Can I do anything else with this? Yes. On problem 1 a long time ago, we were factoring some stuff out front and we couldn't do anymore, but here, this can factor. What multiplies to make 30 and adds up to make 17? 15 times 2. I'll bottoms up right here. So I got 2u cubed. That's still chilling out front. I got u plus 15 and u plus 2. I have to put each of those over 5. That's the rules of the bottoms up. The 5 was the number in front of u squared there. So I get 2u cubed, u plus 3, the result of 15 divided by 5. And on the second one, I can bring a 5 up. What a doozy of a problem. Now in my mind, as I finish this assignment, I feel like to myself, I kind of blew through this a little quick. How long is this video? 20 minutes. 20 minutes is quick. All right. I don't know. We'll see how I feel about that. Let me hit submit real quick. I'm also thinking about having a nice little sneeze. It's not coming out quite yet, but I'm feeling the sneeze. Is it going to happen? Gonna sneeze? No, I'm not going to sneeze. I've changed my mind. All right, let's talk about some problems here. Let's review the types. Problem 1. I factored something out in front of this. I could divide by 3y. These were the leftovers. Problem number 2. It had 4 things. I had to make a 2 by 2 box and then pull out what I could from each row and column, and these were the results. 3 through 5 were all basic factorings where I made a big X and then said what multiplied to make 20 but added up to -9, and whatever those things were became the answers. Simple as that. Problem number 6 looked a little more complicated because it had a number out front of that first term, but on this one I was able to divide everything by 2 and then further factor the results like the previous problems. 7... Was it just 7 and 8? Did I just do 7 and 8 like that? Was 9 like 9 wasn't like that? 7, 8, 9. No, 7 and oh, good job, me. Okay, I tried not to torture you too hard. 7 and 8 were factoring where there was a number out front, you couldn't divide it out. You had to do a little bit more steps than just factoring like 3 through 5. Hopefully you know those steps. I used the bottoms up method when I was going over it. 9 and 10 were special cases. 9 didn't look all that special, so if it doesn't look special to you, you could still do it normal. I mean, when I did it a little bit ago, I treated it like it was a regular old problem. What multiplies to make 64 and adds up to 16? Well, 8 times 8, you know. 10 was a special case because it had only 2 terms, and that's the situation where you want to write the same thing twice, but 1 plus and 1 minus. The purpose of that is it causes -25 to appear, and no middle terms will come out of this, which is good. You don't want middle terms. You don't have a middle term. Then number 11 was the grandfather of all problems. You had to divide out 2u cubed. Then the remaining thing was factorable, but it wasn't just regularly factorable. It was like advanced case factorable where you had to do bottoms up method, and I did it. I guess that boils it down a little bit. So covering it again. We got divide stuff out, factor by grouping, 3 problems of basic factoring, divide out a number first and then basic factoring, 2 problems of advanced factoring, 2 special cases, and then a divide stuff out and then advanced factoring problem. Whew. Will you miss number 11 on the test? I don't know. If you can get number 11, you can get any of these problems, I would say. I have no idea, though. I'm just here making a video. Hopefully it helps you. Thank you for watching this video. If you did, I bet you will do better than you would have done otherwise by watching this lovely video. So I appreciate you. That's all I got to say about that, and I'm going to hit stop recording now. And I hope you have a great time and have a great test. Okay, bye.